Okay, so next up, we would now be determining the allowable resisting moment of the beam. So what we did before was that we have just solved for the actual bending stress, if this would be the moment and if this would be the moment. So let us check if both of these are, let's say, adequate, or let's say if it is still under allowable condition. So for the allowable sections, or for the allowable, what you call this, stresses, we would now be making use of this page in NSCP. So from that, guys, for flexure, for the extreme fiber stress in compression, we would just be making use of 0.45 of F prime C. So that is now our basis. And then for the rebars, so in our problem, we are to make use of 280 megapascal steel. So sorry, 280 MPa steel. And under the code, for 280 megapascal steel, our allowable stress must be 140. So once again, if let's say if I am to copy this section here, so for a moment. So for a moment, I would just be copying it here. So this is now the code provision. And as you can see here, since we are to make use of 280 megapascal steel, it means the allowable is 140 MPa. Okay, so from that, I will just be typing here F prime C allowable, that is equal to 0.45. F prime C and our F prime C is equal to 21 megapascal. So from that, looking at the calculator once again, so 0.45 times 21, so that is now equal to 9.45 megapascals. Sorry. So 9.45 megapascal. And for Fy, allowable. So that is equal to, since we have make use of a yield strength of 280, I should say, sorry. So the allowable must be 140. By the way, this should be FC allowable. So Fs, I should say, Fs allowable. So that is now equal to 140 MPa. So if you would now be comparing all of these stresses, so for concrete, the maximum stress that we have solved for is 8.613. And if you would be seeing the allowable, it means that it is safe, okay? So if the FB concrete is less than the F prime C allowable, meaning that it is safe in concrete. And in for tension, since our FB steel, which is 110.817, it is less than 140 MPa, which is the Fs allowable, meaning that our section is also safe. Okay, so what is the question in question number 3? So in question number 3, you are now to determine the allowable resisting moment. So meaning, guys, that we are now solving for the maximum moment that our beam could carry in WSD. So same thing. So for concrete. So for concrete. So for FB concrete, that is now equal to MC over cracking moment. So assuming that our section would crack. So from that, our FB concrete, let us change that to our FC prime allowable. So F prime C allowable. This is now equal to the maximum moment. So I would just name it as MA times C over ICR. Okay. So what is the value of C? The value of C is same here. So it would now be equal to the value of X. So the distance from the neutral axis of the crack section up until this portion here. Okay, so from that, substituting known values, our F prime C allowable is now equal to 9.45. And our MA is, we actually do not know that. So MA. So the value of C, once again, is the distance from the neutral axis up until the furthest compression fiber, and that is 158.458 as per solved for earlier. Sorry, 458. Divided by the crack moment of inertia. And if you can remember from previously that I have actually stored for it in A. So if this is now our cracked moment of inertia, so if I am to store for it, I mean if I am now to recall A, that is 125,110,3256. So from that, this is now the value of A. Then from that, solving for MA, this is now equal to, so looking at the calculator to your right, that is, if I am to make use of shift solve feature, so 9.45 is equal to alpha x times 158.458 divided by alpha a. Okay, so from that, shift solve, the allowable moment for compression is 74.6 or 74,612,362 Newton millimeter. Okay, so if I want to convert this into kilonewton meter, just simply divide your answer by 1 million. So our answer here is 74.612 kilonewton meter. Okay, so this is the allowable for compression. Okay, so this is the allowable for compression. But what about for steel? So let us also check for steel. And as you can see here that the allowable stress for steel is 140 megapascal. So from that, so Fs is now equal to MC over ICR. But take note that since we are now to talk about steel, we should be multiplying this by the modular ratio N. Okay? So from that, since our Fs allowable, so our Fs allowable is now equal to 140 megapascals. This is now equal to M, and I will also name this as MA times C, and the value of C once again is the distance from the neutral axis up until the centroid of the steel, and that is D minus X. Then our D is 385 and our X is 158.458. So from that, this is times 385 minus 158.458 divided by alpha A times N, and the value of N is equal to 9. So from that, solving for the value of MA, this is now equal to, so looking at the calculator once again, so 140 is equal to, sorry, so once again, 140 is equal to alpha x, so I will now name MA as alpha x, times 385 minus 158.458 divided by alpha A. Okay, so times 9 I should say. So times 9. So shift solving it, the answer for A or MA is 859072726.36 Newton millimeter. So if you would be converting this into kilonewton meter, so just simply divide that by 1 million. So our answer here is 85.907 kilonewton meter. Okay, so we have two answers here. Which one would govern? Okay, so we have this particular value and we also have this particular value. So once again, which one would govern? Is it the lower value or the larger value? So to make it short, this one would govern, which is the lowest value. So the lowest value would govern. Okay, so why is that the case? Because we are asking for the allowable resisting moment. It means that this should be the maximum moment that our beam can have. So if we are now to deal with maximum, isn't it the case that this should be the governing factor or the governing moment? So of course not. It should not be the case. So why? Because suppose that this is the moment that you will be choosing. It is now safe for the steel, but since this moment is greater than this moment, we can now say that it is not safe for concrete. Since the capacity of concrete is just 74.612. However, if you would now be making use of this value, if this value here would now be chosen, it is safe for concrete and it is also safe for steel since the capacity of steel is 85.907. So once again, with that, our answer here is 74.612 kilonewton meter. So there.